Okay, let's dive right into this explainer and set the stakes for what's literally one of the most exciting test flights in the history of space exploration, Artemis 2. If you've been looking up at the night sky wondering, hey, when are we actually going back into deep space? Well, you're in the exact right place. We're going to break down the actual blueprint NASA is using to get humanity back to the lunar vicinity. 50. Think about that number for a second. It has been over 50 years since humans last visited the moon. That is half a century. But early in 2026, this groundbreaking 10-day test flight is aiming to change that completely. We've got 4 astronauts strapping in for a wild journey to the far side of the moon. But how exactly are they getting there, and what are they going to do once they're up there? Here is our agenda for today. First, the Space Launch System. 2, the Orion Crew Capsule. 3, the Lunar Flyby Mission. And 4, meet the Artemis crew. All right, let's jump into part 1, the Space Launch System, building the most powerful manned rocket. So, this incredible vehicle is absolutely the backbone of the whole mission. When that countdown hits 0, this is going to be the most powerful manned rocket ever launched. Period. Let's really get into how this SLS rocket works and how these pieces function in sequence to get off the pad. Down at the base, you've got 2 solid rocket boosters flanking the sides. These things provide that massive brute force thrust you need just to escape Earth's gravity. And a really cool detail, they feature this giant America 250 logo for the nation's upcoming 250th anniversary. It's super fitting because engineers from all 50 states actually helped build this thing. Right in the middle, you can't miss the massive orange core stage. Working with those boosters, it handles the initial ascent. Then, sitting right above that is the Interim Cryogenic Propulsion Stage, or ICPS. That's a fancy way of saying it's the secondary engine that ignites later on to give the spacecraft its final shove into high Earth orbit. And finally, right up at the very top is the Orion capsule where the crew actually sits, capped off by the Launch Abort System. That top tower is absolutely crucial. It's a dedicated emergency rocket designed to literally rip the crew capsule away to safety in a fraction of a second if something goes wrong on the pad or during the early climb. Moving right along to Section 2, the Orion Crew Capsule, a 10-day deep space home. So the crew has actually named their specific capsule Integrity, and it's the only part of that massive SLS rocket that actually makes it back to Earth. For 10 days, this highly advanced little bubble of engineering is going to be their entire universe. Now, the uncrewed Artemis 1 mission was a huge success, but it obviously couldn't test the human-centric features inside. The European service module on the outside powers the craft and propels it, but inside the crew module, it is all about keeping 4 people alive and healthy. I mean, just imagine trying to work out in zero gravity. How would you even do it? Well, they built this incredibly clever flywheel device that works kind of like a zero-gravity rowing machine. It gives them varied resistance so the astronauts can do squats, deadlifts, and curls to keep their bones and muscles from degrading. They're also testing a super precise water dispensing system for drinking and rehydrating their food, this wild in-floor hinging door bathroom system, and maybe most importantly, a deep space radiation shelter. Because figuring out how to survive deep space radiation is absolutely 100% required if we ever want to make it to Mars. Okay, let's look at Section 3, the Lunar Flyby Mission, a high-stakes stress test. Now, it is really crucial to understand that Artemis 2 is not a moon landing. Instead, think of it as a grueling, high-stakes stress test of all those systems we need to keep humans alive in deep space. Launching from the historic Launch Pad 39B at Kennedy Space Center, which is actually the exact same pad that launched Apollo 10 way back in the 60s, let's look at how the SLS rocket works in action on a timeline. Just 2 minutes after liftoff, those 2 side solid rocket boosters run out of fuel and are jettisoned. The launch abort system is tossed too, since they're high enough by then. At the 8-minute mark, that massive orange core stage is totally empty, so it separates and falls back to Earth. Right at this point, that smaller ICPS engine fires up, pushing the spacecraft into a highly elliptical Earth orbit over that first day. By day 4, they're literally slingshotting around the moon. And then finally, on day 10, they come back for a high-speed, fiery re-entry, splashing down right in the Pacific Ocean, where the U.S. Navy will be waiting to scoop them up. But wait, before they even point themselves toward the moon, they have a massive chore on day 1. Once they hit that high Earth orbit, the Orion capsule is going to separate from its booster, physically turn around, and practice docking maneuvers. Why does this matter so much? Well, for future missions, Orion has to be able to dock with lunar landers and space stations. NASA needs to know right out of the gate, does the autopilot work flawlessly? Do the thrusters fire exactly when commanded? I mean, we all remember that recent Starliner mission, right? Where faulty thrusters left 2 astronauts stuck on the space station for months. NASA is making absolutely sure Orion doesn't run into anything like that before sending them out into deep space. So once the thrusters check out, they fire up the engines for that final push to the moon, entering what's known as a free return trajectory. This is just an incredibly elegant piece of orbital mechanics. It's a flight path where the natural gravity of the moon and Earth safely slingshots the spacecraft back home without them having to do any extra engine burns. It's basically a built-in safety net. If every single engine were to fail halfway to the moon, gravity alone would literally pull them back home. It's actually the exact same ingenious flight path that saved the Apollo 13 astronauts. By day 4, they hit the absolute peak of their journey. They're going to be 230,000 miles away from Earth, flying right over the far side of the moon, the side we can never see from our planet. And as they start swooping back toward Earth, the closest they'll get to the stark, cratered lunar surface is just 4,600 miles. I mean, can you even imagine the view out the window at that exact moment? It gives me chills. All right, let's wrap up with Section 4, Meet the Artemis crew, the first lunar crew in 5 decades. Hardware and math are amazing, sure, but it is the human spirit that actually drives exploration. So let's meet the 4 exceptional people trusting their lives to this engineering, making up the first lunar crew in over 50 years. We've got Reed Wiseman in the commander's seat. He's bringing 27 years of Navy experience and 167 days in space to the table. Right next to him as pilot is Victor Glover. He's an elite test pilot who has flown 40 different aircraft across 24 combat missions. Then we have our mission specialists. Christina Cook is an electrical engineer and an Antarctic explorer, and she literally holds the record for the longest single spaceflight by a woman, almost a full year in space. And beside her is Jeremy Hansen. He's a physicist and a Canadian military colonel, actually the first Canadian to ever lead a NASA astronaut class. But you want to know what's truly wild about Hansen? Artemis 2 is going to be his very first spaceflight. Seriously, talk about an insane rookie trip straight to the far side of the moon. So, how will solving the deep space challenges of Artemis 2 serve as the vital first step for humanity's ultimate journey to Mars? As we eagerly wait for this historic launch window in early 2026, it leaves us with a pretty inspiring thought. Testing all these complex systems today, like figuring out exactly how the SLS pushes us out of orbit, how that Orion capsule shields us from radiation, and how we nail a gravity slingshot, it isn't just about returning to the moon. It's really about learning how we are going to survive that epic, months-long journey to Mars tomorrow. Artemis 2 is quite literally the bridge between the history of Apollo and our future as an interplanetary species. So what parts of this mission fascinate you the most? Think about that for a bit, and I'll catch you on our next explainer.